this is a follow-up video for question 31. Now, for this question, most students find the difficulty in not being able to identify the formula to be used to analyze this question context. Okay, so now the question is actually asking you about the brightness of a bulb, and the brightness of the bulb actually comes from power. The parameter that we are looking at is power. Some students may have the misconception that, okay, if I want to judge the brightness, I need to look at the current, or I need to look at the voltage. That is both wrong. You have to look at the power. So now the next question come to your mind is that power has 4 different formulas. It's either E over T, which has no relevance here, or P equals to VI. Now if you use P equals to VI, what happens is that V and I are both changing. Okay, so it is hard to it is very difficult to simply use P equals to VI to analyze whether or not the brightness is going to be brighter or dimmer, or is the same. So some students may think that, okay, I then have to use I squared R. Because R is constant, I just need to look at the I. Then there's another group of students that think that, okay, no, I should use V squared over R. Because, like you say, R is constant, then I only need to look at the voltage. Now the thing about this is that there is no one fixed rule on which formula to use. You have to look at the context. So let us look at this circuit. This is a parallel circuit, a very simple one. So the question is that, now which one should I use? Now in a parallel circuit, you know that your voltage is going to be constant, right? If the battery source is 5 volt, then my resistance is going to be 5 volt, my bulb is going to be 5 volt. No matter how I change the resistance here, it is still going to be at 5 volt. And it's not going to affect my bulb. So just by this simple understanding of parallel circuit, you can already tell that no matter how I change the resistance here, the voltage of the bulb is still going to be the same as the voltage of the battery. And so if that is the case, my resistance of the bulb is constant, my voltage is constant, and therefore my power is constant. And that is regardless of the resistance here. So straight away you can already tell that C is the answer. No matter how you change it, it's going to be the same power, it's going to be the same brightness. So then there's another group of students that argue that, okay, but what if I use P equals to I squared R? Now if you use P equals to I squared R, what you are believing is that, okay, I have low R changed to high R. So when this happens, my current that is flowing here is going to change from low current to high current. And since I am changing from low current to high current, if I use P equals to I squared R, then I must conclude that the power of the bulb is going to increase. Okay, some of you may think this way. Now, what you are saying about this low current to high current, you are actually referring to the ratio, okay, that distribute the current of the main supply. So if my main supply is constant, let's say if my main supply is constant, then what you are saying is correct. But is this main supply going to be constant? Let us analyze this. Now what happens is that when you change it from low R to high R, you are changing the effective resistance of the whole circuit, right? So let's say when the variable resistor is having a low resistance, the overall resistance here is, let's say, 5 ohm. And after you change the resistance here to a high R, the overall resistance has increased to 10 ohm. Okay, let's do a simple test. So what I would do is that let's keep this at 5 volt. Let's apply V equals to IR at the source because I want to find out what is my source current. So if I plug in the value, I find that in the first case my source current is 1 amp. So now I increase the resistance of my variable resistor. Okay, I realize that, oh, my source current actually dropped to half amp. So by increasing the resistance, you are actually decreasing the source current. Okay, and yes, okay, now the ratio when you change it to a high R is going to have a higher ratio of current going to here. But your source current has already decreased. So this decrease in the source current will balance off whatever gain you have in the ratio of this distribution. So if you really go and work this thing out and you plug the current flowing in this branch into the formula here, you will find that actually there is no difference. And it is a very tedious method because whatever resistance value you change here, you have to work out the effective resistance. You need to work out the main current, what is the value. Then you need to work out how much of this main current is flowing into this branch. Then you can work out the power here. It's going to be very tedious because the change in current here is being affected by the change in the source current. So if you use this formula, you will reach the same conclusion, just that it is going to be very, very tedious. Okay, but if you use this formula, you can arrive at the conclusion that the bulb is not going to change brightness straight away because this is parallel circuit. Parallel circuit says that, oh, voltage is the same. No matter how you change the resistance here, voltage is going to be the same. So in this kind of situation, you need to be very flexible. Okay, you need to be able to identify which parameter is going to stay constant. Okay, then you can choose the formula that will give you the answer most directly.